going to be kind of hosting right now what looks like a maybe a quarterly seminar series, kind of just going to different parts of the country, showing where they have, you know, had similar kind of wastewater issues and the challenges they faced, and then how they resolved them with different um, technologies and different policies. And so we'll be going around the country doing this. And so we're really excited to start off with Rob Bolton, whom we'll tell you more about. But first of all, you never forget to introduce yourself. My name is Stuart Coleman, and I'm the executive director and co-founder of WAI, the Hawaiian word for water, but it's also an acronym for Wastewater Alternatives and Innovations. And we're a nonprofit that focuses on water and wastewater issues. And we have been working, even though we're focused on Hawaii, we work with partners around the country. And we are delighted to kind of start with this because we're looking at decentralized systems that we think are going to be very, very important. Because on the spectrum, we have, on the one hand, uh, big municipal systems that are very, very expensive, hundreds and hundreds of millions of dollars. Um, our new Sand Island wastewater treatment plant, just even the renovation alone is approaching $2 billion for Honolulu. And then on the other hand, on the other end of the spectrum, we have individual systems. And so the burden on that is for homeowners to come up with the price of converting their cesspools. And that can go anywhere from 25,000 on the lower range to 45, 50,000 on the higher range, which most people in Hawaii can't just afford a big outlay of that. With financing, and that's an issue that we'll cover in future webinars, that's a potential solution. But today we're talking with Rob because in Vero Beach, Florida, they dealt with similar issues with nitrate overloading, nutrient loading in their nearshore areas. Now, with them, they have toxic algal blooms that kind of are on the surface. Ours are a little more insidious in that you can't see them obviously sometimes, and these are algal blooms on the coral reefs, which suffocate our coral reefs. And so there's been a lot of research on that, but we'll in Hawaii and across the country with rising threats to our coral reef ecosystems. But I'm going to hand it over to Rob Bolton, who's the director of water and wastewater for the city of Vero Beach in Florida. He has got a very impressive bio, but I'll let him tell you about himself. And yeah, thank you, Rob. Appreciate you joining us.
Thank you. My name is Rob Bolton. I've been a kind of native of Florida for about 40 years now and have seen a lot of changes in Florida here with growth and everything else. Received my degree in engineering from University of Central Florida back in 1990. And I'm a licensed engineer and have been working for City of Vero Beach for 26 years. So I guess, Jacob, the best thing to do is just tell you when next slide. Is that how we're going to do this?
Yeah,
Yeah.
that's
So if you want to go ahead to the
Yeah,
next
that'll work.
slide. So Vero Beach is located on the east coast of Central Florida. I'm sure you've seen the Artemis 2 launch. We're about 70 miles south of that. And we are about in the center of the Indian River Lagoon. It's a 156-mile estuary connecting 6 counties together. Next slide. So a little bit of our demographics. We have roughly 17,000 people. We have a medium household income of 70,000. We were mostly gravity sewer, about 75%. Got in the wastewater business in 1925. And we have a central sewer plant and established vegetation, and we're considered a tree city or a registered tree city. Next slide. So what is the problem, or what was the problem? If you can see here, this is part of the Indian River Lagoon. I have some slides of the algal blooms that we started experiencing in 2013. This is a green algal bloom. Next slide. This is a red. Next. Brown. Go ahead, the next one. Green and blue. So we pretty much have the full rainbow effect. Next one. And then this is what really posted and became a problem for up and down the Indian River Lagoon, and that was the health of people going swimming, recreation, water sports, boating, fishing, everything. Go ahead, the next slide. So we started looking at what our problem might be, and we found that we have roughly 3,000 septic systems that the city, inside the city service territory. Many of these were antiquated, failing systems. They're on small 1 acre parcels. Half of them are on the barrier island. Half of them were close to canals draining right to the Indian River Lagoon. Again, there was algal blooms causing concern for swimming and recreation. The nutrient contributions to the Indian River Lagoon, we had excess nitrogen, phosphorus, and bacteria. We started seeing deaths of manatees and lesions on dolphins, and then we started experiencing large algal blooms and fish kills. Next slide. So the county itself, we did a study and we started counting septic tanks. It took us probably 8 months to go in the areas because nobody had any of the data. And we found that there was roughly 30,000 septic tanks in Indian River County itself. And we were responsible for about 3,000. However, our 3,000 were right around the edges of the lagoon and had the largest impact. Next slide. So the area concern that we had was old, broken, failing systems, old concrete tanks dating back to the 1950s with cracks in them. The proximity to the lagoon, we have elevated water tables in some areas, and then we have barrier islands that have just nothing but beach sand, which is a direct conduit to the water, to the water table and to the lagoon. There was a lack of treatment with conventional septic systems. The septic systems, conventional systems probably only remove about 20% of the nutrients. We have soil, like I said, again, soil type where sandy soil prevents direct discharge. Next slide. So here's a typical cesspool. We don't necessarily have cesspools in the Florida itself, but we do have them up and down the East Coast. I think that your concern in that area is in Hawaii is the amount of cesspools that you do have. They were banned in 2005. They are pretty much a direct conduit to the water table and to the to the different water bodies themselves because they're not really doing any treatment at all. Next slide. In Florida, we have a more traditional septic system where at least you are removing bacteria and some viruses, but we still have a huge nutrient pollution. That is why the state of Florida in 2025 banned all new conventional septic systems. They are old conventional septic systems. All new septic systems that can be installed have to be at nutrient reducing, which reduce up to about 60% or a minimum of 60% nutrients. Next slide. So modern sewer was what we had 75% of. We're currently operating a very old, antiquated wastewater treatment plant. However, we're in the process of building a new advanced wastewater treatment plant that'll remove levels down to 5 BOD. Below 5 TSS will be below 1 TSS, nitrogen levels of 3 and phosphorus levels of 1. And now AWT in the state of Florida just last year, or in 2024, they passed that anything within the Indian River Lagoon, you're going to produce reclaimed water to folks, it has to meet AWT standards by 2034. Go next slide. So, what type of sewer and what options did we look at when we decided to go ahead and sewer the rest of the area that was on septic system? We looked at conventional gravity sewer that we were familiar with. However, it was the most expensive. It does have the lowest maintenance. It's affordable at the time of construction of subdivisions, but it's the most costly as a retrofit and the most disruptive to the residents when you're putting it and retrofitting a neighborhood. We looked at vacuum systems. They were gaining popularity. However, they had higher maintenance costs than gravity sewer systems. They're normally not installed for new subdivisions. The retrofit cost was about 70 to 80% of gravity sewer systems. It was less construction disruption of neighborhoods during construction. However, you need a minimum of most people say around 500 to 600 homes to make the pumping station viable from a cost standpoint to as one of the leading to one of the projects if you're going to use that type of a project. We looked at grinder systems. They were less popular than gravity sewer systems. They were used more than vacuum and step. However, they have the highest maintenance costs. We had our staff were highly opposed to looking at grinder systems just because of the additional maintenance. It is a common retrofit and has a low upfront cost. There's other communities in Florida using it, but the total cost was similar to a vacuum and a gravity sewer over time. Um, we finally started looking at step systems. I had some familiarity with as previous city that I worked for. They had about 80 of them that were installed in the 1970s, 80s era. And when I was working there in 1990, they were very low maintenance costs. So that's where we started focusing on. Next slide. Our experience with gravity sewer as a retrofit, we did some projects in 2005. We had 60 homes that we connected. Cost back then, there was no lift stations involved. It was roughly 6,000 to 20,000. Today, those costs they're opening bids that are between 60 and $80,000. In 2007, we had a grant, but we had to have 60% buy-in. We polled 900 residents to look at doing gravity sewer, and there was only 14% of the residents supported gravity sewer because of the disruption, possibility of killing oak trees, and the cost. Next slide. So the social costs of gravity sewer, if you look, that's the equipment that you'll see on a project that's retrofitting a neighborhood for gravity sewer. You have disruption of vehicular traffic. You tear up the roads and the pavement. You potentially damage other utilities. You have heavier construction and air pollution. You have pedestrian safety issues. You have a lot of citizen complaints. We received tons of them with this project. You have increased environmental impacts with runoff because you're tearing everything up. And you have emergency access concerns for somebody to getting in so God forbid somebody has a heart attack and you need the fire department or emergency response teams and they're trying to get around large pieces of equipment. And the biggest thing that everybody was complaining about on our barrier island was damage to their trees since we were a tree city. Next slide. So when we looked at it, just like any project, you look at the economics of it, and the total capital costs are really the sum of the three things below it. And that is the availability cost, which is the cost of installing the lines in the street. Whether you're doing gravity sewer, you're doing vacuum, you're doing grinders, or you're doing step, there's a certain cost with getting the lines in the street to the properties so that the properties can connect. You then have on-lot costs, which are the costs associated with, if it's gravity sewer, abandoning the septic system and tying into the gravity sewer line at the property. If it's grinders, it's installing the grinder package and then tying into the force main. If it's step, it is the same thing, really, installing the step system and tying into the force main at the street. And then for vacuum is very similar to the costs associated with gravity sewer. You then have the treatment cost, which is the cost of either a centralized or decentralized treatment system to treat the waste coming off the properties. We had a treatment capacity to serve, so therefore our treatment costs were just our typical impact fees that we were charging at the time. Next slide. So when we looked at the total cost, this is 2013 dollars. We were looking at that time at $11 million total cost for the unlock cost and the availability cost for a step system. And we were looking at the time 22.5 million minimum for a gravity sewer system. I can tell you right now our costs for effluent sewer have doubled, but the cost for gravity sewer has tripled and quadrupled. Next slide. So our key considerations were keeping low capital costs that we would have to then shift to the person connecting. We wanted to keep low availability costs because that was what the city was funding. So we were going to fund the lines in the street to the properties, and we felt that if we kept that to a minimum, we could accelerate the program. We wanted minimal construction impact to the neighborhoods. We wanted a speed in serving the community so that we got the lines out in a fairly quick period of time, so that at that time it was a non-mandatory, and we had failing septic systems. So instead of people spending money to repair their septic systems, they could connect to the city system. And again, the staff did not want a service grinder pump systems. Next slide. So at that point, I started looking at step systems, and I surfed the web and found Arenco step systems. I contacted Arenco and talked with them and realized that they were, the first generation step systems that I was familiar with in the previous city that I worked for was really no longer what step systems are today, and they were actually on their third generation of improvements in step systems. I felt comfortable with what they were offering. I started contacting some of the other cities. I did that by surfing the web also, and found that South Alabama utilities were using them at the time. There was over 3,000. I think there's probably 5,000 of them now. And then I talked to a little utility district, not little, but they had about 4,000 units in Tennessee, and they were real happy with it. One of the things that I did find out was that the number of staff that I would have to hire to maintain the step system was 400 connections. We currently had one staff person for roughly 1,000 to 1,100 connections, and that is what they were seeing in Tennessee, was one person per somewhere around 900 to 1,000 connections. Young Washington was another. They actually had a very good track record, and they had been operating Arenco systems for about 20 years, and they had only replaced 28 pumps. Next slide. So we started, and the project overview, we started as a non-mandatory program. It is mandatory now with some of the passing of some new laws in 2023. Now it's mandatory that the people that have lines in front of their house have to connect to the central sewer system by 2030 by state law. We went ahead and by city law made it 2028 to try to get them to connect earlier. There was an estimated 3,000 connections that we had to serve. We first started with 93,000 linear feet of 2-inch line in the city of Vero Beach city limits, and we did that in a 2-year period. That ran lines out to roughly 1,500 homes in the city limits. And now we have an additional 80,000 lines, which started last month, to serve the remaining homes outside the city limits. We're expecting that to be complete by December of 2027, so that they can go ahead and have their connections done by July of 2030. Next slide. So here is the Prelos model of an Arenco system. We first started with a 2-tank system During COVID, we had problems with getting one of the tanks for our two-tank system. In the meantime, Renco used to produce a fiberglass tank that was cost prohibitive to ship all the way across from Oregon to Florida. They started making the Prelos units that are a clamshell type design that we actually assemble once we get them here on site. And they're now the preferred installation by all the installers in the area because it cuts way back on time that they were normally spending on somebody's property. So there's the Prelos 1000 and the 1500 step package. They come with a biotube. So if you look in the bottom corner where you see that little blue picture, this is the older model, but you can see down in the bottom there's filters. So all of the waste is filtered before it goes to the pump. The pump is actually a well pump, so they last a long, long time, hence why they can offer you a 10-year warranty on them, and Helm Washington is seeing, 2 to 3% failure rates after 20 something years. We've worked with Renco to modify their control panels. We have actually some backups in the control panels to where we can simply connect a generator to it, small 3,000 watt generator, and pump the system in case of power outages. You just open the panel, you flip a switch, and it starts to pump it down. Next slide, please. So with benefits of their system and the step system is the primary treatment occurs in the tank. There's about 85 to 95% of the removal of fog. Tanks provide a minimum 24-hour emergency storage. We see probably 2 to 3 days. I mean, when you lose power and after a hurricane, you're not living anymore, you're camping. So your water usage goes from about 100 gallons per person per day down to about 40. We expect about an 8 to 9 year pump out with 95% confidence. Our first installation that we performed in April of 2025, we still have not pumped that system out yet. So it's living up to the 8 to 9 year projection that we had. Good thing about the Preludes, any abuses stay in the tank, meaning anybody that's flushing things down the toilet that shouldn't be flushed down the toilet and clogs up a gravity sewer pump station, it stays in their tank and it backs their house up only. And it keeps the untreated septic tank effluent from getting into the groundwater to the nearby water bodies like the Indian River Lagoon. Next slide. So we started with installing 2-inch diameter mains. We follow the contour of the land. There's no lift stations. There's no manholes. It's largely immune to I&I. We use HDPE pipe, which is easy to fix. And there's no major disturbances, vegetation, or traffic flow. Next slide. This picture, if you look at the left, you see the green pipe right by the telephone pole. That's where the bore ended. But if you look all the way down by the stop sign and you see the orange cones, that's where they entered the pipe in. So we're able to do 3 500-foot runs at any given time. The picture on the right is a double service. So we come up with the HDPE pipe and then we convert to PVC, which is then run on the lots to the step systems themselves. Next slide. So here's the on-lot construction. In this case, you're seeing in the top right, a Prelude 1000 being installed. The next picture is that's our modified electrical panel. So the light in the center shows that the power is on to the unit. The light on the top the green light on the top is when it's pumping, and the red light on the bottom is when there's something wrong and it alarms. They go ahead and silence the alarm, and then there is usually a sticker on there that they call us and we will respond. We have lapse times meters, we have heaters, all kinds of stuff in there that is not in their normal package. Be glad to, anybody wants, I'll be glad to share what we've used. We haven't had one electrical panel failure yet in the 11 years that we've been operational. In the bottom, you see more of the floats and the filters on the bottom left. And then there's a hanging discharge assembly where we can easily switch out a pump in less than 10 minutes. Next slide. Oh, this one got messed up a little, but so here's your typical cost of the unlock cost for a Prelos 1000. You have step equipment, you have the installation of the step system, you have the electrical connection, you have the pumping out of the tank and abandonment, and then you have restoration costs. We're seeing right now that typically a Preluce 1000, which will handle 3 bedrooms or less, is about 15,500 on lot cost, and the 1500, which will handle 4 and 5 bedrooms, is roughly 16,700. The new cost for service lines is running about $1,000 a connection, and the step main cost for the 2-inch outside in the street is running about $2,500. We decided to contract directly with smaller boring companies that are really subcontracts to general contractors, and we've been able to keep the pricing down that way, and it's working out real well. Our impact fee, that's the treatment cost, is roughly $22.90. That's low compared to today. You would probably look at something that's 2 to 3 times that cost to actually construct a treatment system, whether it's a centralized or decentralized system. Next slide. So the operation and maintenance of a step system, very simple. We usually look at, well, we were looking at 2 to 3 years, but we've actually gone about 4 years without really doing any maintenance on them. We did start doing maintenance this year, but really it's just garden hose, cleaning the filter off to make sure that anything that has accumulated on the filter now allows it to pass back through and to the pump. Exercising out on the step main, any of the valves that are there, checking air release valves. And then, like I said, the proactive on lot O&M is tank effluent screening, pump control inspection, tank pump outs, flow pump maintenance, and then any type of scum and sludge measurements, and then pump out when necessary. Next slide. So the project status to date, we started with 9 basins originally and provided step system connections to 1,538 properties. We ran the 93,000 linear feet in the 2-year period back in 2015 and 16. We've had over half the people connect voluntarily over the years, and now we started with the mandatory connection for the rest of those roughly 70 or 750 units. We've designed the other 4 basins outside the city limits, but in our service territory. We've started the 80,000 linear feet of 2-inch main. We're estimated to finish that in December of next year. And we have a mandate inside the city limits for 2028 connection, and then the state mandates everything outside our city limits for 2030 connection. We had a mandatory pump out and inspection of septic systems. It revealed that roughly 20% of the septic systems we had broken septic tanks in failure, meaning that they were operating like a cesspool. Next slide. That's it. Any questions?
All right. Thank you so much, Rob. That was a great presentation. Um, if you all can put questions in the chat, that would be great. One question that we'll start with, and feel free to raise your virtual hand too, if you want to ask a question, was someone, Jordan Fahmy, asked, what year are these costs associated with, Rob?
I just updated that cost slide to what we're paying now. So we had pricing that was probably half of that when we started the project. I think it was roughly about $9,000 back in 2013, 14 when we first started our presentations with homeowners. Now we're pushing that $23,000 mark.
Great. Thank you for updating that. And Carl Thompson asks, what's the typical distance from a connection to your treatment plant?
Oh, we have miles. So we have a network of force mains. We can be anywhere from 12 miles away at our furthest point to the treatment plant.
And no lift stations required, just they can
No,
run a
we pump right into the force main network.
yeah.
That's one of the benefits of a step system. It's really a hydraulic model because you're not pumping solids, you're pumping just effluent. So you almost treat it like a water system, and you but you're starting backwards where normally you would start at a water treatment plant and you have large mains and you're trying to figure out what pressure you provide at the homes. You're working backwards trying to figure out what homes are pumping in at any given time, and then sizing your mains back to the wastewater treatment plant.
Great, thank you. And Jonathan Nagato at the Department of Health asked, are all the costs covered by the county government?
No, most of these costs are being covered by the residents. So we fund the availability costs, but then we recoup it when they connect. We have given some credits to the septic system. So where we had impact fees, it was an incentive program where if they connected within 1 year, we waived the impact fee. We really just gave a credit because we can't waive legally impact fees, but we can give a credit for them abandoning a septic tank, which was equal to the impact fee. And then we forgave the availability cost if they paid cash for the equipment and connected within a year.
And then to follow up on that, what do you do for those who just can't afford it? Um,
We were able to work with a local group, and we have some donations. They've gone after. It's first started with an environmental group that gave about $250,000 in donations to help fund homes that couldn't afford to connect, and then they used that money to leverage other NEP state grants and federal grants to expand, and now they're up to about $750,000 in grants that were available. And then what we've done is we've extended the forgiveness program. So where they may have expired at that 1 year period, we reenacted it for any property that they find needs help. We will give credits for the impact fees. We'll also forgive the availability cost, and then they work with the properties. We will actually finance the equipment over 10 years with no interest, and then they pay for the installation on the property. So really, right now, they're for a homeowner, they're paying about $550 up front, and then it's about $550 each year for the next 9 more years to pay. So they're really only paying about $5,500 for the property owners that are of low income.
Great. Thank you for uh, explaining that. And Jonathan Nagato at the Department of Health was wondering if he can reach out to you.
Absolutely.
Questions? Great. So Rob's email and phone number are on the screen, and I just really want to thank him for taking the time. I also want to mention that Rob very graciously will be on vacation in Hawaii this summer, and has said that he can be come in person if people want to talk more and kind of really, get into the details. So we're going to have a Pauhana gathering and a presentation on Tuesday, June 16th. Um, so we haven't finalized the venue yet, but maybe the Pacific Club or the deck at the Queen Kapilani Hotel where we had our convening. And then a quick poll maybe to put in the chat. If we're looking at a time, since it's Pauhana, we could do something like 3:30 to 5 or 4:30 to 6. If you have any preference for that time, please put it in the chat. And then we'll also have another webinar coming up, which we'll talk a little bit more towards the end of the call. But another question was our own Gabby asked, what kind of O&M training is required for homeowners?
There's really nothing. We respond quickly if there's any issues. However, what we did find, and one of the reasons that we got buy-in from everybody on a step system is the homeowners are already living with a septic system in our case, or a cesspool in your case. So they're already used to the do's and don'ts if you don't want to back up into your house. So it was real easy for them to just make that simple transition to a step system because they were usually, otherwise they backed their own systems up. So they were behaving and they continued to behave.
Hmm.
It is a little harder when you have somebody that comes from a multifamily area up in the Northeast that they just dispose of everything down the sewer system because they don't know where it ends up, and those are the ones that luckily the step system will back up once, and then they'll learn their lesson, and they usually behave after that point.
Yeah, that's great. Um, and Carl Thompson asked, what's the approximate monthly cost to the homeowner?
Right now, our wastewater bills are running probably in the $50 to $60 a month range. We do have a cap of 10,000 gallons, but our problem is we have a lot of people use water for irrigation also, so they'll use 12,000 gallons of water in a month's period of time. Where if it's just a residential home that's not using irrigation, they're going to be in the 3,000 gallon, 4,000 gallon range.
And then the that cost includes utility and what else?
Everything, treatment costs, the cost to pump out the system, the cost to maintain the system. We take over maintenance of the system on the property. So if there's anything that goes wrong with it, they call us. We will replace the pumps, the panels, everything, all part of the utility bill. There's
Mm,
no other costs associated with it.
okay, great. Thanks. Yeah, we had in our recent floods here, we have a number of the grinder pump systems out on the North Shore, and they we talked to the director, the county here, and it was there were a lot of failures, as you can imagine, just with intense flooding and debris. Um, so yeah,
Yeah, and they're very hard to change out, and the power requirements for a grinder pump is a lot higher than the cost for a step system. So the step system pump runs on 115 volts, where a lot of your grinder systems are 230 volt. The pumps are 2 horsepower. These are little half horsepower pumps. So the step system is much more forgiving than a grinder system, especially with power outages.
okay. And is there backup if there's a power outage in the tank?
Yes, there's usually about 2 to 3 days of storage. And what we did, we've gone through about 3 or 4 hurricanes. The latest was a tornado that we normally don't have that really leveled an area, and we were able to get out and respond, talk to the residents. But one of the things that we found we were able to do was just buy a little 3,000 watt suitcase generators and take a golf cart out there and just run from property to property, setting them up and pumping them down. And you can just canvas through a neighborhood, and then you don't have to come back for two more days.
Oh, that's great. Um, Ted Bolin, formerly with the Department of Health, asked, how much higher will installation costs be in Hawaii where soils are not all sandy and delivery costs are higher? That's a hard one to answer for you, but
I don't know that, but I was going to, when I make that trip out there, I was hoping to get with some installers, some installers of septic systems. They'll kind of know what and be able to guess what the cost would be. And then also, I see you have directional drilling companies out there. I was going to get with them to see what pricing it was, and then kind of give an update of what I found when I get back for you guys, Stuart.
great. Thank you so much for doing that, Rob.
I
Um,
did see one question on the treatment without the sludge, and that person was correct. Um, we do plan on bringing the sludge to the wastewater plant. However, I would like to make a comment that there is a step system up in Palm Coast, and 90% of their system, it's a 2 million gallon a day system, is step system. Only 10% is gravity, and they do meet requirements. I think they do probably do some carbon addition, but they're not having that big of a problem with treatment at all. But we do plan on pumping out the tanks and bringing that to the plant, and especially the new plant, we have a receiving pit for it.
Great. Um, Thank you. And Barbara Bell from Puaco for Reefs, where they have seen really one of the most impacted communities in Hawaii, where just in the span of 50 years they used to have 70% coral reef cover, and it's down to about 7%. So she would like to follow up with you as well. So
Oh,
thanks for
I'm a diver, so I would love to hear about that.
yeah, exactly. And maybe while you're here, we had kind of mentioned that Puaco might be a place for you to see, and maybe we could set up a talk there. Uh,
Absolutely.
okay,
Absolutely.
great.
There was one there for 12 miles away. Step system is ideal for isolated areas. Grinder systems, which would be the next, low cost system, is not good for isolated areas because you have long force mains that you have to maintain and keep clean. Where step system, you're only pumping effluent, so therefore you don't have to worry about clogging lines.
Great. And Arlene Velasco of the Surfrider Foundation asks, on the east side of Oahu, many homes are more than 12 miles from a treatment plant. Do you have any suggestions for areas like these?
You might want to put in a decentralized system. I'm going to be at a conference here towards the end of this month, and I was going to talk with some of the providers that are there. I know Arenco has some decentralized systems that they could handle probably 600 to 1,000 residents, very small footprint, and then you just operate it locally. There is a benefit for that, especially if you are using the product coming off the treatment as reclaimed water, because then you're not running large mains. You're keeping everything local. Um, it, it's weird. Wastewater industry went from small decentralized systems to the term economies of scale. So everybody had to connect up, and then they had everything coming to one site, and then they realized, what are we going to do with everything now in the reclaimed water, and we can't dispose of it back in the waterways anymore. So the best thing to do is put it back out on grass, and now they're having large costs associated with running mains out to properties again, where if you just keep it local in a neighborhood, it can be very cost effective for everybody.
All right, thank you. And Jordan Fahmy with AECOM said, were these publicly bid projects for the off-lot portion, and are the bid documents available? It sounds like the city's portion of work was not exactly related to Arinco, right?
No, the off lot, yes, we did bid the off lot. The first install that we did, we already had a contract. We had an electric system at the time, and they used a underground installer for all their 2-inch service lines. So we just used that contract, but we just did bid out, and we now have a contractor that we can, and we had, I think, 5 bidders, so we can give you the all the bids to see what the spread was.
All right, great. Um, and yes, Barbara Bell, to incentivize you, says in Puaco, yes, we have diving and a guest house. So Uh, yes, you'll be in good hands while you're here. Jonathan Nagato had to run, but he said thank you for the presentation, and he'll be in contact. Walker Noe of with Regen, who's helping with some projects in Hawaii, is an engineering firm, says given that the effluent is anaerobic, are odor control measures typically included at discharge points to gravity systems and/or wastewater treatment plants? Um, and then there's
So
some
we
other
try.
question, but we'll go with the
Yeah,
first.
I get it. We try to pump right into the force mains. So where you normally have a gravity sewer system, and then you have a lift station, and then you pump to your treatment facility, we try to tie into those force mains directly so that we don't have any odor issues in the gravity sewer systems. If we have to tie into the gravity sewer system, we don't typically do it at a manhole. We'll do it right into the line itself so that it keeps the odors to a minimum also.
All right, and then thank you. His second part of his question was, if systems expand past the initial master plan, what are typical bottleneck points? And can the system be boosted with an online booster?
Yes, if you're looking at just an effluent system, yes, you could easily do an online booster.
All right. And then Jacob with Vi says, if you're interested in helping us develop responsible management entities to develop sustainable water solutions for Hawaii communities, please fill out this interest form here. And maybe I'll ask Gabby to come on. We received a grant from the EPA for rural, small, and tribal communities to develop these RMEs. And this will give communities, and we're going to have advisory councils that kind of will break down silos and bring people together so communities can really be more informed and have more kind of input in the decision making versus their water and wastewater. Um, Gabby, do you
I
want
think
to?
that's very
Yeah.
important, Stuart. We had that here. We had a group called the Clean Water Coalition, and the person that kind of was involved in founding that was probably in my office once or twice a week while we were going through this, just pushing me up the hill to make sure I didn't step backwards. So you have to have those groups involved in projects like this, and I commend you guys for realizing that in the very beginning.
Great. Thank you. Gabby, do you want to jump in?
Sure. And I can just share, I'll just share a few quick slides, but I also dropped in the chat our website that has a lot of the information. And let me just make sure, yeah, okay, my microphone's on correctly. I'm going to just present very quickly, just a few things. I promise this will be very short. We are starting, this is through an EPA, Rural, Small, and Tribal grant. So we are helping create Hawaii's responsible management entities. And to do that, we're creating an organization consisting of diverse stakeholders with technical, managerial, and financial capacity to not only help with the initial cesspool conversions, like, for example, a community that might be interested in converting their cesspools to this system that Rob has described, but then also to come up with the long-term business plans and operations for the sustainability of the system forever. And so what we are going to do, everybody knows why we need them. We talked extensively about the importance of it. But this project has pretty much three core objectives, and it's to help design a stakeholder and community training program. So we'll be utilizing WAI's Work for Water program, where, and instead of tailoring it to the next generation of on-site wastewater professionals, we will be tailoring this training course specifically to utility workers, service providers, legislators, county officials, community leaders, educators, anybody who really is involved in this process of converting cesspools and managing them long-term for their community. We will also then be creating technical assistance workshops for communities on Maui County and Hawaii Island. So this program is just specific to Maui County and Hawaii County for now. Our goal, though, is to have people from across the islands and nationally who are involved in these kinds of efforts so that we can create a model that can be scaled statewide. And then the goal, again, is not only to just help convert these cesspools, but also to help communities access funding, like specifically accessing the Clean Water State Revolving Funds and diversifying their funding sources using other private, local, state, and federal funding sources. So we've got a nice 3-year timeline here. This is all on our website that I put in the chat. But if you are interested in joining our RME collective, we're basically opening this up. And so we're using a PICO model, which is an Olelo Hawaii term, that's really going to ground us in this way of Hawaiian organization, always coming back and bringing back to the center and communicating and sharing insights and feedback through these different channels. But for now, the way you could get most involved is we're going to be hosting our first collective meeting the second week of May, most likely Tuesday, May 12th. At 9:30 a.m. Hawaiian time, and you'll be receiving emails soon on that. But essentially, if you want to be part of this collective, you can come, you can learn more about the project, and then you could potentially decide if you want to join a subcommittee, and in order to be a little bit more involved in the curriculum training and the workshop development, or provide specific TA or services. And if you just want to kind of be involved or you're interested in what we're doing, you can always just join the collective, and we'll meet about once or twice a year. And we will convene at WAI's next annual Innovations in Sanitation convening. So this is just a little roadmap. I'm not going to go through all of this with you all, just kind of share. May 12th is our date. If you want, you can email me at gabby@bycleanwater.org. And that's a little bit about responsible management entities in our project.
Thank you, Gabby. And it's a very
My
exciting
pleasure.
development for us. While we wind down with the webinar, I think Micah Kajimoto, did you have your hand up?
Hey Rob, I'm involved with some propellers designs here in Hawaii. So you guys, you funded and installed basically the main lines within the right of way.
Yes, we funded. We started with. If you look back in that 2013 timeframe, we had an estimate that the lines would be $885,000. So the city more or less dedicated $1 million out of our water and sewer fund to go ahead and install the lines, which then we slowly recouped as people made connections. Some of it was forgiven with the incentive program that we had, but yes, we started the funding with city funds.
So part of that project, did you guys install laterals to every lot and up to the property line?
No, we actually installed the 2-inch lines, and then we went back as each one wanted to connect and install the lateral lines. We require the contractor. So part of this is we use septic tank contractors because they were used to installing septic tanks. Step systems are very similar to that. By using the septic tank contractors, also we didn't have people coming in and crying that we were putting them out of business. In fact, they actually have more business now than they ever did with all these conversions. And so they'll actually do a plot plan. They'll come in, show the house, the street, and where they think that they need to tie in with the 1-inch line, and then we go out and install the tap at that point and the valve, and they connect up to it.
So the homeowner was responsible for the on-site work then? They had to get their own engineer, their own contractor to do the tank, the control panel, and then connect to the lateral.
So the way that we worked with the Department of Health at the time and now the Department of Environmental Protection is once we permitted it, it had the size and really an explanation of all the connections. They didn't require engineers to design the system at that point. They used our typical details, and the septic tank contractors themselves did the installation of the system. But the homeowner contracted directly with the septic tank contractor so that we didn't really get in any disputes over the sod doesn't match or you destroyed my tree and all the other stuff that we wanted to avoid.
All right.
If
Well, I
you
think that's all we have time for. Sorry, Micah, we're winding down. Um, if you have any further questions or want to, I put the information about the Pauhana gathering that we're having um, on June 14th, June 16th rather. That's Tuesday, June 16th, and we'll be sending out information about that, the wheres and whys. Would love feedback if I think Barbara said for outer neighbor island folks, they prefer an earlier time, so maybe 3:30 to 5. If you all could just, give a virtual hand thumbs up if that works for you all, that would be great. Get a sense of the time. And then our next one we'll do is going to be focused on Suffolk County. And in the chat, I put an article that I just wrote about how they're dealing with over 350,000 cesspools, and have done really well. But let's also, if you know how to work your little React features at the bottom, let's give Rob a big hand. He's just a very devoted public servant and has just done a great job explaining this. And is willing to come up and follow up with us in June out here. So, Rob, we can't thank you enough, and we look forward to seeing you in early June.
Look forward to it.
All
Have a
right.
great day now.
Hope you all have a great day, and thank you for joining us. This is our first session, and we're really pleased to have someone like Rob lead us off. All right. Aloha, everyone.
Aloha.
Well,
Thank you.
Aloha. All right. Great job, Rob. Thank you so much.